All right, morning everyone. So I'm going to totally shift the topic of conversation here for a couple minutes. We're going to talk about redistricting, gerrymandering, some social science stuff, and how that intersects with data science. So quick review, what do I mean when I say redistricting? So every 10 years, we take the census, we get new population numbers for every part of the country, and on the basis of those numbers, we're going to redraw city council districts, state house districts, congressional districts, with the goal of making sure that each have equal populations, right? So as populations change, we've got to rebalance the districts. And that should be a very boring, very bureaucratic process, but in fact, it's totally the opposite of that, because how you draw the lines can end up having a really big impact on who gets elected. And so that's, once people realize that, right, that becomes then a very important site of political contestation. So that manifests most often in the form of gerrymandering. And I'm sure people have seen some graphic like this, but the idea is, like, let's say you have like a little mini state like this with an equal number of Democratic voters in blue and Republican voters in red. If you draw the lines one way, you end up with 3 majority Democratic districts and 1 Republican district. But if we draw the lines a different way, exact same population, suddenly we reverse that balance and the Republicans have the majority. And so if you're a party, you're obviously going to pick the set of lines, or you'd like to enact the set of lines that favors you. Okay, so when I put two things side by side like that, it's easy to see the impact that lines can have, but it's actually much tougher to look at any individual redistricting plan and say, oh, is this gerrymandered or not? Is this plan fair or not? And to give a great example of that, so I just moved down from Massachusetts a couple months ago, and in Massachusetts there's 9 congressional districts, and they're all represented by Democrats, okay? But 1 in 3 voters in Massachusetts is a Republican, okay? So there are 1/3 of the votes, but 0% of the seats. Show of hands, is that gerrymandered? Okay, we got a couple, some people shaking their head, okay? Well, it turns out no matter how I draw the lines, it's actually impossible for there to be a Republican majority district in Massachusetts. The 30% Republican voters are just spread so evenly over the state. There's no area where they're a majority that's the size of a congressional district, okay? So that's an example of you can take the most extreme outcome. You could not get a more favorable Democratic outcome in terms of seats, and that still wouldn't be enough to definitively prove that something is or is not gerrymandered to favor that party. But identifying when things are gerrymandered is actually a big problem, right? Like, as voters, we want to know if the maps are fair. And then, like, if these things end up in court, the court has to sift out, should these lines be allowed or should they not? So how do we actually go about determining that? So the big idea that's sort of taken this world over in the last 10, 15 years is what we call like an ensemble analysis. And what I mean by that is you're going to come up with a big collection of random redistricting plans. The lines are drawn randomly, and they're drawn without, in particular, any partisan data. So that they're like a non-partisan baseline. And specifically, what I mean by that is, like, we're going to define some probability distribution over all the possible plans, and we're just going to, and that distribution is going to be non-partisan. There's going to be no preference for plans that favor one party or another. And then if we can just generate a whole bunch of random samples from that probability distribution, we'll end up with this big old collection, or an ensemble of redistricting plans. Once we have that, then we can go through to each plan and we can say, okay, in this plan, on average, how many seats are the Democrats going to win? How about this plan? How about this plan? And you end up with a distribution over stuff you care about, like the number of Democratic seats. You can look at the distribution over how compact the plans are, or how many people they put in each district, or what the racial composition is. And once you have these distributions over like what you'd expect, basically the range of what you'd expect under a nonpartisan baseline, then you can compare. Okay, here's the plan that the legislature actually passed. Is it lying in the middle of that distribution? Is it about in the range we'd expect what's typical, or is it an outlier? So we're basically doing a hypothesis test where the null hypothesis is like, this plan is fair, it's representative of this nonpartisan distribution, and then we're testing that null hypothesis by generating a bunch of samples and comparing and seeing if our actual observed plan is an outlier in any dimension that we care about. So the big question for researchers then is, okay, well, this is a great plan, but how would I actually go about making this collection of nonpartisan plans? Turns out to be a really tough problem. Even in a state like, I'm going to show you an example of Iowa here. In Iowa, you draw districts based out of counties. There's 99 counties. You put them into 4 districts. Okay, it doesn't sound like that hard a problem. In Iowa, there's like on the order of 10 to the 24. So that's quadrillions of quadrillions, different ways to draw redistricting plans out of contiguous districts. And if you toss the ones that are kind of weirdly shaped or don't have very equal populations, then you can get smaller, but it's a huge number. In New York, there's like over 10,000 precincts and into dozens of districts for Congress or the State House or whatever. So the number of possibilities quickly is bigger than like the number of atoms in the universe. Okay, so you can't just like list all the options and then like see what the deal is, right? You're going to have to come up with something fancier. So what I've researched is ways to do that. I'm just going to give you like the picture version of an algorithm that we've come up with. The idea is you're going to start with a blank map of your state, in this case Iowa, many, many copies of it. So I'm going to have 5,000 blank maps. And then on each map, you're going to draw one district randomly. And you do this in a particular way where you can actually calculate what's the probability that I ended up drawing this particular district using my procedure. So you can keep track of these probabilities. You're going to go through each of the random districts you generate, and you're going to score them. Okay? Does this one align with the criteria that I need in a redistricting plan? Is it compact? Does it balance the populations correctly? There's other criteria you can put in place about trying to preserve cities, boundaries, and all this kind of stuff. And then, so each of these plans gets a score or a weight, depending on how well it aligns with these criteria. And then you resample, you reshuffle the plans according to these weights, such that plans with like better scores, better redistricting plans are more likely to make it to the next stage. And as you do that, you also draw a random new district. And you keep doing this process of scoring, shuffling, and redrawing until you've filled in the entire map. And it's not obvious from the schematic, but you can actually keep track of the probabilities and weights as you go through this whole thing such that you can actually show, you can prove mathematically that what you're left with at the end of the algorithm is representative of this nonpartisan distribution of plans, this baseline that we're trying to approximate. And that's not something that we could do before. So there were a lot of algorithms that tried to do stuff like this, but they were very sort of ad hoc, and we had no idea what they were really generating. And now we can actually show that this is mathematically representative, and that gives us more confidence that our conclusions are not going to be distorted by weird aspects of the algorithm or any hidden biases that have crept in. Computationally, we can sort of run each of these maps on like a different computer core if you want, so you can really scale it up huge if you want. So you can generate thousands of plans in very big states in a matter of minutes. And so that really allows people to sort of apply this everywhere very practically. And we also had developed a set of diagnostic measures and ways of monitoring this algorithm so you can make sure that what you're actually getting is what you want and it isn't sort of breaking behind the scenes for you. This is all implemented in some open source software that we've seen people around the country use. Journalists have picked this up, people across academia. So the goal is not just can we come up with an algorithm, but can we also sort of make this accessible to people who want to then apply it to their local city council or whatever. So just to wrap up with a little bit of, so first actually, so here's an example of what you get out of this algorithm when you run it. So this is the state of Ohio and its congressional districts. Not much to see other than that, these look like redistricting plans. They're pretty compact. They're following county boundaries. You must have to take it on faith that in fact these satisfy all the legal criteria that are required of redistricting plans in Ohio. But to give you an idea of what you can use this for in practice, those plans I showed you actually came from a lawsuit over congressional districts in the state of Ohio that we were hired to consult on as expert witnesses. So we get brought in by the American Civil Liberties Union, and they say, can you do these simulations to show that the plan that the Ohio legislature passed is an outlier? It favors the Republican Party to an extreme amount. And so we generated plans like the one I showed you, and we're able to demonstrate that yes, in fact, the enacted plan was an outlier. And on that basis, the congressional map was struck down in 2021 by the Ohio Supreme Court. So you can use this in litigation, and courts have found it very convincing because, and you can see, you have these example plans right there. It's sort of an intuitive thing, like, here's what would have happened if parties weren't in control of the process, and here's what actually happened, and let's compare them. But on the academic side, we can do something similar. So we actually did a project where we ran simulations like this in all 50 states for all congressional districts, and we ended up with a collection of sort of like 5,000 whole national maps of possible congressional districts. And what lets us do is things like this. So we built this really cool map of every single congressional district in the country, colored by how gerrymandered that particular district is. So like if it's really blue, that means that this district ended up more Democratic than it would have otherwise, and if it's really red, then it's more Republican than otherwise. So like right now, we're in the New York 10th, and we can see that we did not get gerrymandered very much. Okay, it'd be kind of hard to gerrymander because Manhattan's just so blue. Doesn't really matter how you draw the lines, you're going to end up with a pretty strongly Democratic district. But other places, Texas is really bad, Illinois is really bad. You can see there's a lot of manipulation. So this was a team of grad students, undergrads, pre-docs, faculty, and we did all these simulations, and we were able to sort of do this kind of national analysis using these tools. That's all I have. QR code if you want to read more about this, but I'm happy to answer any questions, and thanks for letting me come and talk to you about my research. Yeah.
Yeah, I have a question about the map you were showing.
Yeah.
So some states have like both colors are present.
Yeah.
Is that indicative that like they're essentially packing certain districts in order to carry them in the whole state, or is it sometimes the case that like even a state like Minnesota, which has an independent commission, just like by chance kind of ends up gerrymandering a little bit of both sides?
Yeah. So there's always going to be some things. So like these states have commissions. Michigan has a commission, Colorado has a commission. So there's, you're always going to see a little bit. There's other ways of testing, specifically at an overall level. And you will see there's always going to be a mix of red and blue because if you're going to put more Democrats in one district, that's going to put Republicans in another district. So there's always some kind of trade-off. But it doesn't exactly cancel. So like you can look at Utah here. It's all the districts are red. They take Salt Lake City and they divide it up like pizza slices so that each part of that Democratic city gets spread out into a red, Republican district, and the result is 4 solid Republican districts. So a lot of different strategies. There's other sort of ways of analyzing this, but we kind of like this sort of district map. It's like a big overview, and then you can dive into other stuff. Yeah. Yeah.
So I know Cory
Yeah, so I'm actually just, I do work on this, but I actually don't think that we should, at this point, have computers just completely draw the maps. There's just a lot of factors out there that are important that a human has to sort of take into account. One of those is like communities of interest. So it's a very slippery thing, but I mean, we want, for example, if there's like a linguistic minority or like an economic interest, we want them to be in the same districts, that they can like concentrate their voting power and have a representative who's like incentivized to look out for them. But like there's just so many different ways you could define a community of interest. It's very hard for a computer to say, okay, this is an interest that needs to be protected, and here's exactly how it's going to get balanced against these other considerations. So I think it's a really good tool for measurement. It's a really good tool for identifying gerrymanders. There's work being done on sort of coming up with the best plan, but I think there needs to be a human in the loop at the end of the day. So I'm actually happy when how we win in court using this technique, but then a human special master gets appointed to draw the maps ultimately, because they can balance those considerations, and they're politically accountable, right? Like there's a person you can go to with your complaints, versus like the algorithm, set me up in this district, and now, this person I don't like is representing me. Yeah. Active area of research. Certainly if you can come up with, for example, like some numerical measure of like like, here's a precinct, and these should be together this % of the time. Like, if you have like for every possible pair of precincts, like a similarity score or something, you can feed that in, and we can work with that. Coming up with that, of course, is the huge challenge. So it's like, how do we work on, how do we integrate survey data and demographic data and commute data and all this stuff into like some kind of way of defining these things? It's very hard, but yeah, working on it. Quirky rules. There's some, I mean, Ohio's actually a not horrible example. This is not from days of old, but so actually the citizens passed a referendum in 2018 saying, look, we're going to throw out the political process and have a commission, and there's going to be a bunch of rules that constrain the commission. One of those rules was no partisan gerrymandering. That's how we won in court. But the other rules were like these really bonkers things about like county splits. So it's like, if your county has a population between this 100,000 and this 100,000, then it can only be split a certain number of times with a certain number of districts. Actually, we think a lot of those rules were sort of like snuck in there as a way of like disenfranchising voters in the city. So the Republicans actually wrote rules that were designed to just target, Cincinnati or something and mess around with that. But you get some really Baroque stuff. Many states actually don't have any rules at all. Literally, there's not a single place in the state code or constitution that has anything about redistricting. So like anything goes. So yeah, we hope people are better, writing out rules, and there's a lot of progress there too. Of like, what's a good set of rules for all this? But yeah, we have one more.
One quick question.
Yeah.
You kind of touched on this there, but could you use this to like test the effectiveness of the rules? By being like, if these rules will compress
Yes.
the distribution versus other rules. Like, 'cause I know I've talked to people about this a little bit. Oh, well, you should just basically cancel the counties and that'll solve the problem. But obviously it's more complicated, right?
Yeah, in the old days, people would have, like, you could kind of just see a gerrymander because it was very windy and wiggly. These days, people have gotten a lot more sophisticated, and you can have a district that looks totally reasonable, but actually it's gerrymandered. So I think we haven't gotten yet to the point where like, the research is yet informing reforms, but like we certainly have the tools now to like compare, like here's plans you get under one set of rules, here's the plans you get under another set of rules. How does this change the partisan distribution? How does this change the demographic distribution? All this stuff. So I think hopefully that'll sort of make it back into policy in the future. I'm going to stick around for lunch, so if you want to sort of find me later, happy to chat more. Thanks again.